entry-1. And I am Syarifah Fasha with matrix number 225285, and today we will explain about question 3, which is about elastic collision, which we learned in previous chapter 9.
Explain generally about elastic collision. In physics, an elastic collision is an encounter between two bodies in which the total kinetic energy of the two bodies remains the same. In an ideal, perfectly elastic collision, there is no net conversion of kinetic energy into other forms, such as heat, noise, or potential energy. In a simple word, elastic collisions means that the particles moving separately before and after the collision. During the collision of small objects, kinetic energy is first converted to potential energy associated with a repulsive or attractive force between the particles. Then, this potential energy is converted back to kinetic energy. To get more understand about this topic, Alliyah and Fasha will explain about question 3. But before we go straight into the question, let us watch a few videos about elastic collision and its concept.
Break down some collisions.
Yeah, sure, man. Here you go.
Wonderful. So the main two concepts to know for elastic and elastic collisions are conservation of momentum and conservation of kinetic energy. Remember, the equation for momentum is P equal mv, where m is the mass of the object and v is the velocity of the object. For elastic collisions in one dimension, conservation of momentum applies. That means the sum of the momentums of the objects before the collision is the same as the sum of the momentums of the objects after the collision. We can write that as m1v1, the momentum of this first object before the collision, plus m2v2, the momentum of the second object before the collision, is equal to m1 v1 prime, which is the momentum of the first object after the collision, plus m2 v2 prime, which is the momentum of the second object after the collision. As you can see, the sum of the momentum before the collision is equal to the sum of the momentum after the collision.
All right, let's take a look at conservation of energy for elastic collisions. So remember that the equation for kinetic energy is 1/2 mv squared, where m is the mass of the object and v is the velocity of the object. So for elastic collisions, we can write this down as 1/2 m1 v1 squared, which is the kinetic energy of the first object before the collision, plus 1/2 m2 v2 squared, which is the kinetic energy of the second object before the collision, is equal to 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared, where this is the kinetic energy of the first object after the collision, and this is the kinetic energy of the second object after the collision. So as we can see here, the sum of the kinetic energy before the collision is equal to the sum of the kinetic energy after the collision, meaning that the kinetic energy for the total system is conserved.
Hey, let's do some more examples in real life. Here we have two still disks. This would be our object 1 and this would be our object 2. As we can see here, object 1 stayed roughly in the same location as object 2 before the collision, and object 2 moved at roughly the same velocity as object 1 before the collision. Let's do it again. Okay, let's look at some more examples here. Here we have two marbles colliding into each other. The marbles bounce off each other at roughly equal and opposite velocities, signifying an elastic collision.
Let's take a look at one more example, this time with these two identical cars bouncing into each other. As you can see here, the velocities of the cars after the collision is significantly lower than the velocity before the collision. Let's look at that one more time. So this collision is something we're more likely to see in real life because no collision is truly elastic. This is because the kinetic energy of object 1 is never fully transferred as kinetic energy to the second object, as a lot of the energy is dissipated as heat, sound, or even deformation into the object. Elastic collisions are still important as they provide very good models
Collisions!
of what a collision should be under ideal conditions. My name is Himmel,
And this is Kiarash.
and this has been Elastic Collisions.
To solve this equation, first we need to use the kinematic equation to find the final velocity of the blocks before the collision occurs. After that, use the final velocity as the initial velocity after the collision to find the final velocity after the collision. To find the final velocity after the collision, we need to substitute the initial velocity that we found earlier in the elastic momentum equation. We will get the final velocity in terms of r using the substitution method after adding the two equations of elastic momentum.
It's time for us to find the maximum height after the collision for both blocks. We need to use the conservation of energies formula and substitute the final velocity into the equation. Finally, we'll get the mass for block M, which is 25r over 36, while the mass for block 2M is r over 36.
Thank you, that's all from us.